Good afternoon, guys, ladies and gentlemen. Nice to see a nice full room. Thanks for coming. My name's McAlister. I'm an actual real engineer most of the time, or sometimes I'm just the mascot for the team. But I actually work on the project, and we got a bunch of our team members here today as well, so we'll be able to answer kind of any questions you have. But today what I'm going to do is I'm going to go through, I'm going to deep dive on some of the new features we've released with RDS Postgres. We'll talk a lot about sort of questions that we get from customers and some of the things that we've learned about Postgres and just sort of about running a large number of these over the last 2 years as we've been running this as one of our engines in RDS. So let's start right away with what's new in storage. So we recently went from a 3 terabyte limit to a 6 terabyte limit. So this doesn't change the maximum IOPS today. That's still around 30,000 IOPS, and that's mostly due to the limits on the machines about how much network throughput they can get. But the nice thing is with our general purpose storage, or GP2, because you get 3 IOPS per gigabyte, now that you can have larger storage, that means you can get more throughput and more IOPS. And I'll talk a little bit more about why that's such a great deal for GP2. The other big one that we had a lot of requests for is we had a request for encryption. We have a lot of people that have compliance, and so now we support encryption at rest. And this is across all of our engines, and it's actually down at the storage layer. And we do this through KMS, or Key Management Service. So that's part of our identity and access management. And you get to use your own key, or you can use a default one. But I'll tell you up front, use your own key. Because at some point, we're going to have sharing of encrypted snapshots. And when you do that, you're going to need to have your own key if you're going to do that. So if you're using the encryption, choose your own key. And this is at all levels. So this is your data files, your log files, your backups. All the pieces are encrypted. So no. So no. This is at the storage level.
Yeah. So this is specific for RDS Postgres.
Yes. This is a specific feature for RDS Postgres, and it's part of the actual RDS overall platform that we do. Is it? Sorry. What was? Is it? I do not believe it is not on Postgres at the moment. So one of the first questions I had when I presented the previous slide at another conference, someone said, well, what is the overhead of encryption at rest? And I said, that's a good question. I will go find out. We had done some tests, but I wanted to go back and run it with pgbench because we'd done it on some of the other engines. So this is just doing pgbench, read-only, TPS on the vertical axis, pretty common, right? And in the green, you can see unencrypted, and in the blue, encrypted. Now, of course, this is read-only in memory. You wouldn't expect any difference, right? So there is no difference when you're just doing reads, in memory, that is. So when we go and do the PG read-write test, and this is actually, for those who use pgbench, the write test actually does a lot of writing, probably more than some applications do in normal use. So again, we have the vertical axis, and you see around 16 threads where we start to see a bit of a difference for the encrypted. It's a little longer latency, just a tiny little bit, so we get a few less transactions per second. But even at the max, what we saw was about 5 to 10% overhead. And it is an overhead that you have to decide whether it's worth it or not. But if you do have compliance that you need to do, I think it's worth it. And over time, we think that this will continue to come down because Intel does better and better jobs on their CPUs about being able to handle offloading encryption. And it's not supported on all the types because not all of them have encryption offload, so that's one thing to consider. One of the other big ones that we had a lot of requests for from customers around storage, it was around our snapshots. So these are basically, you can take a backup whenever you want. You just take a snapshot of your database. Or every night we take a system backup that is also a snapshot that you can use. Now customers said, look, but I've got a prod account, I've got a test account. I can't share stuff between them. So we just announced here last month the ability to sort of share snapshots. So you take a snapshot you have of your instance, and you say, I would like to share this with a particular account. You choose that. You can share up to 20 by default. We can allow you to do that more. Once you've done that, it's really simple. It's just like restoring from a snapshot. You can copy it, or you can make a new instance. So one of the interesting things about this is because you've shared it out, as soon as you've done that, someone can obviously copy it. So currently, we only do this for unencrypted ones because we're working on the encryption one involves doing some stuff with keys that we're still working on. But one of the other cool features that you can do with this is you can actually share it to the public. So let's say you had a really cool set, PostGIS data with some really cool stuff. Instead of giving someone a data dump, now you can actually say, hey, go be able to get a Postgres database, just spin it up and start using the data right away. So we think there'll be a lot of kind of cool use cases for this feature in the future. The other thing I'm really happy to announce is that we now support major version upgrade. I think the official announcement is going to go out tomorrow, but it's live on the site. You can go and take your RDS instance today, and you can upgrade it from 9.3 to 9.4. I'll walk you through how that works. So you start with your prod 9.3 database. The first thing we do is we take a backup. And the reason why we take a backup is that we use PG upgrade, and before we get started, we want to make sure we have a good copy. Now, the other thing we do is we take a backup at the end of PG upgrade, because we want to make sure that once it's done, we have a good copy as well. But mostly, the reason why we do this is that you can't do point-in-time recovery on a database during PG upgrade because it's not actually transactional. It's moving some stuff around, it's creating new system files. So to make it safe, we want to give you restore points on either side so that if anything happened or you need to recover a database for whatever reason, you have that. And this is going to take about as long as PG upgrade does take. So that's going to vary with the amount of objects in your database, including databases and schemas. Now, this looks pretty simple, but what I tell people is that's really not the best way to do this, right? The best way to do it is to go make a test copy of your database, do the upgrade of that, then go and check out for your application and make sure everything works, and then once it's done, go do your prod one, right? And this is really important because PG upgrade checks a lot of stuff, and we do those checks as well to make sure that the upgrade's going to work. But running a relational database, as you guys know, is very complex. You can do a lot of stuff with it. That doesn't mean it's 100% foolproof. So you always want to do this kind of testing before just running this on your production system. Plus, it'll give you an idea of how long PG upgrade is going to take and how long your system would be down for, so when you get to schedule the production upgrade. So the other thing that we just released was a couple new versions, 9.4.5 and 9.3.10. The 9.3.10 is not really that remarkable. We just, it's the new version along with an updated PostGIS and PLv8 minor versions. But 9.4.5, we actually put in a lot of new features from an RDS perspective. We added 3 new extensions, pgstattuple, pgbuffercache, and IP4R. And I'll talk a little bit more about both of those. We added autovacuum logging, I'll get into that, as well as super user reserved connections. So the additional logging, this gets around to compliance again. We had a lot of customers that said, I like that you administrate my database, but I want to be able to audit all the stuff going on. So now you can actually force the admin logging. So this is anything we do with the RDS admin account in your databases, you would see now if we do any kind of action in the database. But the one we've really got a lot of requests for was the auto vacuum logging. Because we run as RDS admin and that's what auto vacuum ran as, there was no way for you to turn on logging that would enable vacuuming. So we've now added a new parameter that allows you to do that. So for example, if you had normally wanted to set your log auto vacuum min duration to 5 seconds or 5,000 here, then you would normally turn on just a level of logging that would show you that. But now you do RDS force auto vacuum logging level. So if you set it to log, and this works exactly like all the other ones, you can go all the way up to debug, 1, 2, 3, whatever you need. But log is typically sufficient. And this is an example from one of our databases where what you will see is that once you have logging turned on, any statement that cancels auto vacuum, you'll actually see that in your log, and you'll be able to be like, oh, I'm not able to get vacuuming done because of something I'm doing to the table, so you can actually take action to correct whatever your application is doing to allow logging to continue. And you can go all the way, like I said, if you go to debug, you get all the information about what auto vacuum is doing, all the timings, how much work it's doing. So that's a new feature as well. pgstattuple, how many people use pgstattuple? Few people. I know Josh was one of the people that asked for this one, so I'm sure he'll be happy to see that it's made it in. So this is a nice tool that allows you to basically figure out how much space is in your data that's not being used, that's freeable. So in this example, I ran a sysbench against a database, and this is one of the tables, that SBT test 30. And what we see is that after running for a while, I have 3.45% free, and okay, cool. And so if I do a regular vacuum, I get more free space because it basically cleans up old dead tuples. But you'll notice that my tuple percentage is still where it was until I do a vacuum full. So now you can see that we actually compacted the table by doing that, and you actually end up with no free space, but you also end up with a smaller table. So this is really handy for managing, sort of the bloat in your database based on when you're vacuuming and how you're churning through tuples. The other thing that we had a request for was how many people set the reserved super user connections on their database? It's a good idea, right? Because if you have your application connecting and it overwhelms the number of max connections, then you can't get into the database to do anything about it without basically, killing your application off or bouncing your database. So let's say you have max connections set to 20. Well, normally you'd think I can have 20 connections. But that's not the case in RDS, of course, because we have the super user reserve connections set to 3, which means the most you're going to be able to do is to do 17 connections. Because this actually comes out of the max connections, so when you set max connections, you actually have to, look at that. So this was good for us. We were able to get in and manage your database and do things, even if you use all the application connections. Of course, the problem then occurred that if you had your application running, you couldn't get in to kill queries or do anything if you filled up all the connections. So what we've added is a new parameter, which looks exactly like the other parameter, but except for it has RDS at the beginning of it. And so here in the example, we're setting it to 3. By default, this is turned off in the current 9.4 release. I think when we do 9.5, we'll probably, by default, enable this. So what that means is now you could only have 14 connections in this example, but you can always get in and kill queries. Of course, the really important thing is you can't have your application connecting as the RDS super user. You need to go create a less privileged account to go connect. Otherwise, it will just use those reserved ones as well, and you still won't be able to get in. So that's really handy from a administration perspective. The other extension that we added was PG buffer cache. And I'm going to talk a little bit more about sort of some cache buffer settings later on in the talk. One of the things I talk about is working set. And how can you tell how big your working set is in memory, right? Before, without this extension, it's very difficult. So now what you can do is you can query this, and this is just a simple query that just says, hey, give me the free versus used for my database. And you can see in this one, I was only using 31% of the shared buffers, so I could actually lower the shared buffers because I don't actually need this much RAM configured. So, and you can do all kinds of cool settings. One of the interesting ones that I had was, how much of an effect does it have running something against this? And I actually ran a query just continually, so it was running about every 4 seconds on this box, and had no real meaningful effect on the performance of my application while I was doing that. It might be like some percent, but it was so small that it was basically within the jitter of sort of normal benchmarking. So one of the other ones that we were really happy to announce at our reInvent conference here in November, or in October this year, was sort of enhanced operating system metrics. Because one of the things that we heard from our customers was, we really like RDS, but we don't like the lack of visibility to a lot of key OS metrics. They said, I love running top, and especially on Postgres where you can see a lot of information. It's kind of painful not to have that information. So we're coming out with enhanced operating system metrics. They're going to come out first for MySQL and then later for Postgres. Still expect it fairly shortly, though. And the one that I'm most happy with is sort of the process list. And so this is where you're going to be able to see what your process was doing, and you can get the granularity down to like 1 to 5 seconds, and literally see, you could say, what was my autovacuum process doing for the past 2 weeks? Exactly for how much CPU, how much memory it was using. So it's going to be really powerful. It's like a top that does recording for you. And so this is going to show up, in nice metrics that you're going to be able to view, over time. And we're still working on the final layout of the GUI, but this is kind of what it's going to look like. And there's a lot of key metrics that people use today to administrate their databases. So the other thing that we worked a lot on over the last year was data movement. We've had a lot of customers really ask us to make that easier, so we've done a lot of things in that area. The first is we announced a new AWS data migration service, or DMS as I like to call it, which allows you to go from pretty much any of the major databases, Oracle, SQL Server, Postgres, MySQL, our Aurora database, to another database. And we call it a migration service, but it's really a replication service. And it really allows you to move data from one place to another. So how this might look if you were doing a migration is you start with your database on-premise or in EC2. You have a VPN, or you just connect to your database, and you get an EC2 or RDS instance. And you start a replication instance, and that's a little thing in the cogs. I didn't do this graphic, by the way. It's a little more fancy than I do. So you set that up, and it's going to be just like an RDS instance, where you go and you say, hey, I would like, an M4, large migration service. and you start it up in your VPN, or VPC, sorry. Once you do that, you say, hey, here's my source database, here's my destination database, bam. You've got those connected. And then you go through and you select basically what tables do you want. You can take everything. You can just take some databases, some tables, whatever you'd like. Once you do that, it does a full load as a select, so that you always have to have the ability to have a consistent select over a long period of time, depending on the size of your data. We've seen it take about 11 hours to move a terabyte, depending on your internet or your connectivity. And then the cool part about this is, the real thing I like about this service is it uses change data capture to pick up from the logs the changes that are happening on the database. So since you've been doing that full select, you're basically getting all the diffs, and it's being applied to your target. Once that's done, basically you have two databases that are matched up, continually running. You shut down your application on one side, you start it up over here, and you're golden. So this can work, like I said, either with EC2 or RDS. Today for Postgres, we can use any EC2 or on-premise database that's 9.4 or above. And the reason for that is we're using the logical decoding that was added to 9.4, so that's why it's a requirement. Now, today we don't support with RDS Postgres as a source, but that's something that we plan on doing in the future. And if you're interested in this, we're in preview right now. The slides will be up later, but that's the link to where you can go sign up for the preview. So we think this is going to be very powerful long-term for doing things like, hey, if you want to move data from Postgres to Redshift, or you want to convert from one database or another, or you just want to do some form of logical replication, you'll be able to do that with this tool. The other one I talk a lot about is sort of, just the, good practices on loading data. We get a lot of questions from customers on this. All the normal stuff here, disabling backups, turning off our multi-AZ offering, turning off autovacuum. Now remember, you have to turn all this back on in the end, but you want to make it easy for the database to do stuff. You want to use compression if you're using pgdump, parallel restore. One of the big ones you want to do is increase the maintenance work memory. Today we start off with a very small default because of the way our parameters work, 16 meg, I believe. That's much too small if you're actually going to do a big bulk load. It actually makes a big difference. And the other one is you want to increase your checkpoint segments and your checkpoint timeout. And the reason for this is Postgres has to write full copies of the blocks into the wall stream after a checkpoint. So we see customers, if they have these set small, do 2 to 3 times as much wall writing as they need to. So it's really something you want to tune if you're going to be doing a lot of data loading. And this is another one that's been around for a long time, disabling fsync. And this is the one that we actually disagree with. We don't think it's a good thing, because essentially when you're doing that, you're putting your database at risk for corruption. And you can say, well, look, but I'm fine taking that chance. It's okay, I'm just loading for a little bit of time. But if anything happens to your database during that time, your machine crashes, you're going to have a possibility of corruption, and you're not going to know it. And so that's the scary part, is you can have corruption somewhere in your database because it didn't write some portion of the data or other things to disk. And we've seen this with a lot of different things, extensions, does some really weird stuff. What we do recommend is disabling synchronous commit. It's basically the new modern way to do the exact same functionality, but in a completely safe manner, where it just delays writing to the log. You can lose some data, but you don't end up with corruption. So of course, one of the things we want to do is we wanted to test this and show the performance. So here I'm doing an insert test, which isn't necessarily the normal way to do bulk loading, but it's one way people do stuff. So on the vertical axis, transactions per second again. And I start with 2 different checkpoint segment mounts, just to show you kind of some differences there. The blue at 16 and the purple at 256. So this is 32 threads inserting. So you see with both of them turned on, increasing the segments helps a little bit. But when we turn fsync off, you can see we get a dramatic improvement, which of course is why people told people to do this, right? It worked. But the interesting thing is if you turn synchronous commit off and you have fsync on, you actually get slightly better performance. Now, if you turn both of them off, you actually get the best performance. But if you look at this, it's 4%. How many people want to explain to their boss why their database was corrupt because they loaded data 4% faster? I know I don't want to. So in general, that's why we recommend this. And the big jump up, as you can see, was just turning sync commit off, basically doubled the performance on this test. Now, the more typical way to do bulk loading with a copy command, and this time we're vertical axis is time in seconds, so we want a smaller is better. Now notice that the checkpoint segments actually made a large difference here right off the bat. With both of these on, just increasing the checkpoint segments is a large increase. When we turned fsync off, we didn't actually really get much of an improvement at all, right? Because it's bulk loading, it doesn't actually do that much syncing. And that's the same for synchronous commit. You'll notice in these tests that changing, the checkpoint segments was the much more important thing to do. And even with both of them off, again, it's a 3% improvement to turn off fsync. Not something I would recommend. So one of the questions we get a lot is really around scale and availability, both just in general for Postgres and for RDS. And one of the questions I get a lot is, how should I think about setting my shared buffers? And we have some very large boxes. Our R3 at extra large is 244 gig of RAM. So you need space for your Postgres processes, right? They need memory, depending on what you have your work mem set at. Then you need to set your shared buffers. By default, RDS sets it to a quarter of your overall RAM. So in this case, 60 plus gig. And then the rest is going to sit in your Linux page cache. And what's really interesting about this is Postgres is one of the few databases that actually uses both its own shared buffers and the Linux page cache. So it's kind of different to tune than some of the other ones. So when you go do selection of data, essentially what you're doing from your PG process is going to look for that data in the shared buffers. And if it's not there, it's going to go basically ask the OS for it. If it finds it in the Linux page cache, it gets it. If not, it goes all the way out to disk, in this case, EBS for us, and then goes all the way back. Now, so you can imagine that if you go to shared buffers, instead of going to the Linux page cache, you're going to get a little bit of reduction in overhead because you're not having to do that extra work, right? So general recommendation is shared buffers, get it set to around the working set size. Now, the interesting thing with Postgres is that this works until the shared buffer, until the working set doesn't fit into memory anymore. Because then there's a whole bunch of problems with sort of page eviction algorithm. Not a whole lot of problems. There are problems. And that can cause, really bad performance problems depending on what's going on in your system. So this is a general rule. You'll want to look at your own situation, but that's our recommendation, and here's why. Went and ran pgbench, write workload on an R3 at extra large. And basically my benchmark was 10% of the memory of the box. So in this case, it was 24 gig that my working set was doing. So I've ran this test, again, transactions per second on the vertical, with different sizes of shared buffers along the bottom. So you can see 3, 6, 13. So that red line basically indicates everything on the one side of it doesn't fit into the working set, does not fit into shared buffers. And on the right-hand side, what we see is that it does. And of course, what you get is, you get about a 5 to 6% performance improvement by not having to go down to the page cache to find those same blocks. So everything fits in memory here. We're not going to disk, but we're just the difference between shared buffers and hitting the page cache. Now, the other thing you'll notice is having shared buffers set a lot larger than you need doesn't help you as well, right? There's no additional benefit if it's bigger than working set. Now, of course, most people aren't going to buy a box that has 244 gig of RAM for a 24 gig working set. So the more sort of common one would be something like, hey, 50% of your database, fits in RAM. So in this case, we do the exact same test, but in this time, the 13 and 25 don't quite fit, and the others do. And we actually see even a bigger increase here. We saw between 3 and 20% on our test improvement by only going to the shared buffers. And the improvement gets larger with basically the number of threads and the amount of concurrency that you're doing. So, again, a lot of my stuff is not to say this is the absolute right thing to do, but it shows you that testing these things with your system and making small changes can actually get you quite decent wins on performance. The other one we get a lot of questions about is our multi-AZ offering. Most people that run Postgres are very familiar with sort of wall-based replication. We do that as well, but we have a platform-level feature called multi-AZ. You start with an application, a database in one availability zone. In our regions, we have multiple availability zones. People can think about them like data centers, but they're not quite. We usually recommend that you have replication of your database between one availability zone and another in case of a disaster, in case of something going wrong. For most people, we also recommend having the application be residing there as well to make sure that you know how to have everything working in the event of some kind of issue. So in this case, both the applications are connected to the primary. And we do physical synchronous replication. And the reason we like physical, just like walls replication is physical, is that it's very performant. and it doesn't tend to have the problems that logical has. Logical is very handy for doing things like migration and replication, but it tends to be not that great, and we have a lot of experience with that with MySQL. So the synchronous replication, the important piece there is, the reason why we want it to be synchronous is so that we can fail you over without losing any data, right? If it was asynchronous, you wouldn't be able to 100% say all the data is over there. So we really like physical synchronous. So in the case of your primary going down, what happens is we fail over the database to the other side, and that looks good, but wait, my application's still pointing at the old guy, right? So how do we do this? We use CNAMEs, and we update DNS whenever we do a failover. So once that has happened, we go and do this update, and that tells the applications, hey, go connect over here. So this all takes about 65 seconds to happen from detection, failing over, starting up. Now, it can take longer if you have a lot of recovery to do and you don't have enough IOPS on your database. But now with GP2 and PIOPS, we usually don't see too much of that. And this works whether it's just a small problem on your one database or a larger issue like a networking issue in one of the availability zones. And of course, we repair the secondary, we get it back and going, we get you back to a durable state as soon as we can. So the piece that most folks are familiar with, Postgres-based replication, we also offer for folks that don't need that kind of durability of a synchronous replica, or for read availability as well. So here I have our multi-AZ setup, but I can add read replicas to it, and you'll see that that flows off of the primary to these, like example, 2 read replicas. And what you can do is you can actually divide your application to use your read replicas. And this is very common in the MySQL world, and we're seeing it more and more in Postgres now. Let's say you had a blog application. Well, your writers, they need to write, so they would be in that blue writes, and they want to consistently see what they just wrote. But everybody reading your blog, they don't need to see the absolutely last updates that were done, right? So you could have them go read from the read replicas. And by doing this, you basically increase your read availability. So in the case of a failover or multi-AZ, while that failover is happening, right, you can continue to read from your read replicas. And notice that we've promoted the primary, and they will now feed the read replicas. So nothing breaks when we do this. It all continues to work fine. And then once the failover finishes, you'll be able to write again. So this is a nice way to pick up read availability. And this works, for example, if you were doing an upgrade, you'd be able to, go ahead and do, to that for your reading at the same time. And if you need to modify one of the read replicas, you can have many of them, so you can always have something that's available for read. Now, one of the funny things about read replica promotion that we do that's a little different than a lot of folks is that we don't do any following. So you can see I have that read replica in AZ3. When I promote it, it just becomes a new primary. You can do all the things you would normally do with an RDS instance, and you can put a new application on it, you can do whatever you want. But notice it doesn't change any of the stuff on the other side of the picture. None of the other read replicas start following it. There's no sort of parent-child relationship here. It's just, it becomes a new guy. So that's more useful in the sort of MySQL world where they do a lot of changes. In Postgres, because it's physical, this is mostly used for availability if you needed to promote in the case of a failure. And then the other thing, of course, is read replicas for scale. The nice thing is you can have a lot of them. You can put them in different availability zones. So you can actually have your application connecting even closer. That's one of the benefits that, some people, if they go, hey, I really need like that half millisecond in latency, you can get that by really placing things really close. But, not usual. So when we've set up the replication, we had a lot of questions from customers about what were the things that they had to consider and think about now that they're setting up read replicas using wall-based replication. So we do streaming replication between the primary and the read replica. But one of the things that we noticed with Postgres was, well, if you break that, the problem is you start accumulating logs on the primary while it's broken, and you will do that up to, the time where you hit your wall keep segments. And then, once they're gone, they'll get deleted. Except for the nice thing for us is we're always uploading the logs to S3 as part of the backup and recovery. So when that log gets removed, well, it's not a really big deal because we've got it in S3 and we can play it manually on your read replica. So we'll switch back and forth from streaming to sort of log apply, if necessary, if the stream gets broken. And then once it gets back together, it goes back to streaming. So this is a nice sort of thing that we've done to try to make this a little simpler for folks running these. How can you tell what mode you're in? pgstat replication. You can just look at things like this, and you can see that, hey, we're in streaming state, which, you know, in asynchronous. The other one that we get a lot of questions on is sort of around MVCC and read replicas with Postgres. So in this case, I have a table. I have a row in there called a-foo. Let's say on the replica, I start a select star from T1. Well, that happens to be, you know, a terabyte-sized table, and I forgot to put a where clause on it. You know, that's going to run for a very long time. I'm sure nobody does this to any of your guys' replicas at all, right? So meanwhile, on the primary, someone does an update to that row and sets it now to bar, right? This is fine. We have MVCC. We just create a new tuple. We're all good, right? And this will get replicated down to the replica, just exactly like we'd see. Now, the replica, because of its snapshot, is going to just be looking at that old row. This all works great. Till someone runs a vacuum or autumn vacuum runs on the source. What that's going to do, it's going to remove that old row, right? It's gone, great. But then we end up replicating that same change down to the replica. And what ends up happening is you get this nice error. And a very unhappy user who has been waiting like 2 hours for their query to return, it's now dead, right? So there's basically 4 methods to control this behavior, and I'll talk about each of those in detail. So vacuum defer cleanup age is probably like the one that I would not recommend because it's a number of transactions. How many people think in numbers of transactions? Most humans think about time. So you thinking, well, that's a very interesting. That's good. It's got some work for you, I think. So let's say you have a table and you're modifying the rows, right? So you have lots of old tuples. And let's say you're on your replica, you're trying to select for T4, right? Well, you know, you keep going more tuples, and at some point, we vacuum, and it's going to remove all those but the current one, right? So in this case, you could have set vacuum defer cleanup age to 2, and it would have left you those extra 2 rows. But again, this is not set on a per table basis, right? So you've got to actually calculate the transaction changes across the whole system. It makes it pretty much impossible to come up with a working number on this. The much more classic way to do this was to use the max standby archive delay or max standby streaming delay to set the time that you basically want to use. So in streaming mode, if you set it to 30, what this is going to do is delay the apply of a change for 30 seconds if there's a conflict, right? If it's going to do something that would break one of your queries. So this works great, except for that. Remember how I said that we will switch from streaming to wall apply? Well, so you need to have both of these parameters set if you're going to be running an RDS, because if we switch to the other one, we will end up, you know, applying them and breaking your query. So you want to have both of these set. The bad part about this parameter is it only delays it once. So if you're behind, you're up to date, it delays it for 30 seconds. That transaction, your query finishes, all great, but the next guy comes in and it conflicts. Well, it won't delay another 30 seconds. It's already 30 seconds behind, so it will immediately apply that next statement, and it will break your next query. So that's the problem, is not all sessions will see the same level of delay. So that's kind of the tricky thing. Now, this one is nice in the fact that it doesn't do anything to your primary. Your primary is always just, you know, doing whatever it needs to do. It's vacuuming. It's like there's no changes, so you don't have a lot of debt kind of building up, but it's kind of complex to set the right numbers again. The one I like a lot better is hot standby feedback. This is sort of one of the newer ones. So again, if we're talking about doing streaming replication, the way to think about this is it's on the replica, you have to turn it on, it's off by default, and it sends basically a back channel back to the primary to say, hey, there's stuff going on the read replica that you need to know about. And it makes it look like, when you have a select, it makes it look like to the primary that it's running on the primary. It's not actually running on the primary. But from an auto vacuum perspective, it's going to do things now like you had a query running on the primary. So it won't basically vacuum that table while this is going on. Now the challenge with that is, of course, if you have this turned on, you can end up with a lot more bloat in your system because let's say you had 3 or 4 replicas all doing different stuff. It's like having 3 times the activity on your main database for the kind of things that will block vacuum. So it's definitely something to be aware of. Now remember again that if streaming replication breaks, we'll switch to going to the wall archive apply. Well, if streaming's broken, so is the feedback loop. So at that point, auto vacuum will again kick in and you can still have queries broken. So you probably still want to set the other parameters as well in addition to this one. Yeah. What do we set as default? None of them are I don't think any of them are set by default. Because again, everyone's, some people don't want any delay. They would rather kill all queries on the replica. So, it really depends on your sort of business use case. So we since it's not sort of a required parameter, we don't set a default. How you see this is you go look at pgstat database conflicts. And you can see here where I had a conflicting snapshot, and that's because I did a vacuum and it broke. So this is the way for you to see, what's happening in your database, why things are breaking. Another really good thing to use to see what's going on in your database is pgstat statements. We added support for this a while back. How many people use this? Pretty much everybody? Good, yeah. I mean, it's pretty much the best way to sort of see what's been going on in your database from a performance perspective. Now, the interesting thing with this one is you have to load it as a shared library and an extension. So this is where I tell folks, by default, you don't have to have a parameter group. We give you a default one. The problem with that is you can't modify that one. So I always tell people, go create a custom parameter group for RDS right off the bat. Go, set up these kind of things as your standard stuff and use it on all your instances. The other area that I think is really cool that's going on, with sort of cloud computing is this idea of burst mode. This is something we introduced a couple years ago, and we've kind of continued to add to it. So we have two different kinds of things. We have one is instance classes. So we have the T2 family, and this is it allows you to burst up on any credits that you don't use. So if you get a certain amount, you don't use them, you store up credits, then you get to spend them later. So you can burst higher, and I'll show you what that looks like. The nice thing with the T2 line, you get CloudWatch metrics, which I'll show you, that show you what credits and how you're using them. We just introduced a while back GP2, which was the other burst mode companion to this, which is an SSD-based storage, but it's giving you IOPS as your credits. So you get 3 IOPS per gigabyte. If you don't use those 3 IOPS, you store them up, and then you can burst. And so this is really nice because it allows you to actually have some variability in your workload and not have to have buying way too much. So on the T2s, you can see I've got a benchmark running here, and the green line is my CPU, and the little red line is my credit balance. So I was using them up because I was at full burst, and you can see that once I run out of the credits there at the bottom, that my CPU drops because I'm at 0 credits. So I'd have to basically stop the benchmark, and it would build back up. Unfortunately, at the moment, GP2 does not have CloudWatch metrics for their burst stuff. That causes us a lot of customer conversations where folks say, what happened here? And we have to say, well, it's because you ran out of burst. But it is something that is being worked on. What's new in this area, which is really cool, is we added a new larger class. It's called the DBT2 large. So it has more initial credits. You get more credits per hour and higher base performance compared to the previous models. 8 gig of RAM, so it's not a very small box, more I/O bandwidth, and the best thing is it's a new instance, so it supports encryption at rest. So we had the encryption at rest, we talked about that, it was great, but let's say you were running an R38 extra large and you're like, I want a test copy of my database. You were forced to buy a much larger box because you have to run it on one of the instances that support encryption. So this is nice now that there's a smaller instance class that will support that. So why is all this important? Well, this is all important because it provides you very good cost for performance. And I wanted to do some benchmarking to show you that. So again, transactions per second on the vertical axis. And I started by looking at a run of a 24-hour run, basically doing the same thing over and over again. And I started with 100% read workload, 20 gig of data, and so the data does not fit in memory. So we're definitely doing some amount of I/O. This is one of our older classic instance types, the M1 medium. And I was using 200 gig of the standard storage. Danny's making faces that he's like, you shouldn't be talking about these. So this is magnetic storage. It was fairly low performance, and you paid a fixed amount for the storage, plus for every million IOPS, you paid like some amount of money. So I ran this one. It was 58 cents an hour, and we got about, I think it was like 12,000 TPS off of that, right? What's interesting is I went and got one of the newer models, the M3 medium, and I actually upgraded it to PIOPS, our provisioned IOPS, and I put 200 gig with 2,000 IOPS on there. What's cool is I'm actually paying less for that newer model, even though I've bought like basically better stuff, and I'm getting almost, 2,200 transactions per second for less money at 40 cents. So that's good. And I thought, well, I should throw a large in there and just see what it does, see how much that would help my workload. And it does help a little bit, because a little bit more memory, right? I can get a little more stuff in cache, so I don't need as many IOPS. I get a little more work done. What's funny was in this test that the price per transaction was exactly the same between the M3 large and the M3 medium, so it was actually a pretty worthwhile upgrade. But the cool thing is when you start looking at the burst mode, guys. So this is a T2 medium. So it's got the exact same amount of RAM as the M3 medium does and the M1 medium. But it bursts. And so you can see that after that first 2 hours, we're actually doing more TPS for the first 2 hours than any of the other ones. But of course, we hit this little curve, just a small little hiccup, right? This is because we've run out of our burst credits. So once we ran out of our GP2 credits, we can't do as much IOPS and it drops dramatically down. But look at that cost. It was 10 cents an hour, right? So if you only needed that kind of burst for 2 hours a day, you're basically saving, a huge amount of money on your cost to run that database. But the cool thing with GP2 is, because you get more base IOPS by adding more space, I was like, well, let's just go and make it a terabyte instance, right? And run it again, because now I'm going to get base 3,000 IOPS. So that's more than I had on the M3 medium or the M3 large. And we get 6,000 transactions per second. Now, we still run out of GP2 credits, but because we bought more storage, our base is still a lot higher, and we stood at 4,000 TPS for a long time, almost 18 hours before we finally hit the cap on the instance where the T2 is actually now being throttled, and we slow down to about the same speed as the M3 medium. But look at that. So at the very end, it's still basically half the cost, almost half the cost, of the M3 medium, and it performed much better for most of the day, right? But what's really cool is the new instance class. So that's the T2 large. So it was doing 12,000 transactions per second. Now, there's two reasons for this. One, remember I said it had more I/O capability, so that means it can do more IOPS per second, right? Because it has more network bandwidth. And it actually exhausted the GP2 credits sooner because it could use them up faster, right? But the increase of the RAM means less IOPS again, so we're still at like 5,000 transactions per second for almost the whole day, and it has a higher base ceiling, so out there at even hour 21, even when we finally hit the cap, it didn't actually reduce the CPU that much because we really weren't using the full CPU on the box. And look at that, 30 cents an hour now. So you can imagine if you have a workload that says, hey, for 2 hours a day, we get just hammered on, you can actually use something like this and save yourself a lot of money. So these techniques, and you don't have to use GP2 with T2, you can use these separately. And what I tell folks is that essentially if you need less than, let's say, 10,000 IOPS, GP2 is the right way to go. It's going to cost you about a third of the amount of money that PIOPS does and give you almost identical performance. So it's a way to really have a well-performing database for a much lower cost. And so with that, I will wrap up. Oh, I had the circle on the 12,000. And take questions. Sorry? We will post the slides, so they'll be available on the website, yeah.
So on multi-AZ system, major upgrade, will it still take long time?
On multi-AZ, the question is, will a major version upgrade take a long time? Yes, because that's the upgrade is happening on the database, and so you have to be upgrading the database. So, well, there is no two databases. There is really only one database, right? And because of the way we do physical replication, you can't do an upgrade. So this is something that, as sort of BDR and the logical replication stuff proceeds down that path, we hope to, over time, to be able to possibly do things with either our replication service, DMS, or that to allow customers to do more seamless upgrades, which I assume will kind of become the norm for Postgres, over time, right? Yeah, in-place PG upgrade, yeah. And that's what we take the backups ahead of time to make it, so we don't have to do copying of the data, right? Other questions? Sure, I'll take one from you.
So the data migration into RDS.
Yes.
What's the mechanism for that?
The mechanism in, so the question was, what's the mechanism? Do you mean from the source, or do you mean what's the? From the source, yeah. So from the source, we have different sort of tool chain for each engine that we support. So, But for Postgres, it's using the logical replication piece that was put into 9.4. Yeah, so it basically uses the hooks in every engine, whether it's Oracle, the same thing as like that been going on a long time with Golden Gate and other products. So same sort of techniques to do change data capture there. Over there? So how do you migrate from EC2 instance to RDS? So that's where the data migration service is perfect for that. So that will allow you to basically do essentially an almost zero downtime migration inbound today. So yeah. Sorry, any? There shouldn't be any database level changes that need to be made. There's permissions that are slightly different, but for the most part, unless you were running your application as a super user, it should work. Can the target for the data migration service be used as a read replica? Yes. So that would be a logical replica, which would allow you to do different things than you can do today with like sort of a physical-based replica. Yeah. So even though we call it a migration service, basically my assumption is over time it will be mostly used as an actual replication engine. Oh, sorry. Okay, yeah, the question was, can you make schema changes during the migration? No. Today, sorry, that's not true. We do have, for our DMS system, we do actually add triggers to do stuff on sort of on top that allow you to sort of do things. In general, what I would recommend, though, is usually you don't want to be making a lot of changes to your database while you're doing something like that, because it just makes everything much more complex, right? Yes, Josh?
Okay, I have another question from the internet. One extension author wants to know how he can pitch you to include this extension in RDS.
I like donuts and beer. No. The question was, how do you get an extension added to our list of extensions? You have customers ask us for those extensions. That's really the primary driver. This is why we added the ones we added, is because customers have come up and said, hey, here's ones I need, and we keep adding them. Now, there is obviously security aspects to our managed service that don't allow us to do unsafe extensions. So that's one of the things that we look at, as well as sort of the history of the extension. If the extension was born yesterday and has like one user, probably not something we're going to add right away. But how do they communicate with Amazon? Yeah, that's a good question. It somewhat depends. I mean, the forum is one way for us. We read the forum. We have conversations with customers. We talk with our account management, our salespeople on a regular basis. So depending on what level of engagement you have with the company, and then people send me emails. So that's that's the other way. Let's go far back. Is the data migration tool just data migration? Yes. It'll do, because it can go from like, no, but we have another tool for that. We have a tool called the Schema Conversion Tool, SCT. We really like acronyms, you can tell. That tool today only does Oracle and SQL Server to MySQL. We do have future plans to make that happen for Postgres as well. So we get a lot of customers that say, I'm on Oracle, I would like to be on something else. Usually the answer is Postgres, right? So that's definitely something we got a lot of feedback on. Other questions? Yes. Yes. Yeah, so the question is, you don't have HBAconf privileges on RDS, and that's true. So today your basic mechanisms are, doing, auth and security groups in like a VPC or in your network, and that's essentially what we do today. We've had a bunch of requests around the HBAconf, and it's something that we're looking at doing, but we're still trying to understand what would be the requirements. So maybe we can talk later about what your specifics would be. Is there any plans for a Postgres compatible Aurora? We've been getting a lot of questions from customers. It was actually one of the first things that most customers asked us when we announced Aurora, because there obviously are a lot of customers who like the functionality of Postgres, but like the idea of what we've done with Aurora. So it's something that we're getting a lot of feedback from, and gathering sort of input, I would say is.
We see a lot of vendors like XYZ, Quadrant, Citrus DB, they contribute back to open source. Will Amazon plan to do this?
Well, we do contribute back to open source. Not everything. I mean, so we have submitted bugs and we have submitted patches. We do have people doing changes. I think it comes down to two things. One, whether we think the things we've done are useful to other folks, and two, just basically on the usual decisions that companies make on how much to contribute. But no, I mean, we do have a general policy that we do give back to some degree. Other question. When are you going to support 9.5? When's 9.5 going to be released? Yeah. So we actually had a bunch of conversations with customers, both at reInvent and over like the last couple of months, and we asked them, "Are you going to run 9.5.0?" And pretty much all of them said, "No, we'll wait for 9.5.1." Right? So that's kind of our current plan, is to release when 9.5.1 comes out. Now, that being said, in the future, what we want to try to do is we want to try to get an environment where people will be able to run release candidates and other betas, because we've heard like a lot of folks saying like, I like RDS, but I want to be able to play with it, and I don't want to have to go back and do something else. I want to be able to play with it in the environment. So it's definitely something that we're looking into. I think it would be great for both us and the community, because I think it would help with the testing of the new releases, just making it easier, right? Other questions? Yes. For the migration tool, the question is, do the versions have to match? No, they don't. It's logical. I mean, you can go from Oracle to Postgres, so you can go from any versions of anything you want. Now, obviously, if you have something, if you're going down, that would be kind of bad if there's something that you're missing in the future one, right? But yeah, so that would be, like I said, that might be a way for people to do logical upgrade in the future as well, right? Any other questions? Do we have a script? Yeah, it's like a one-click button, and you, yeah. Yeah, so but that's the SC2 tool is basically, it's a desktop tool that you go and you run against your database, and it comes back and says, here's the things that we can convert, here's the things we can't convert. Then you basically go do those, and then you can move the data. And I mean, the nice thing is the feedback we've gotten so far on the tool is great, is that customers say, if nothing else, it tells me the areas that I'd have to go change. Because it can go find, it can go look at all your stored procedures, it can look at all your code and say, oh, you have these problems that aren't compatible with this other engine, right? So for folks even thinking about doing it, it's a great tool just to kind of do that. So I think, we're getting really good feedback on it so far. Anything else? Okay. Cross-region replication. Looking at one of my developers. Yeah, it's definitely something that we believe is an important feature for all of the engines in RDS, and it's one that we've gotten a lot of feedback on. So it's definitely something that we're planning on doing. I can't give you a date at this point, but it is definitely something we want to have. I mean, obviously for a lot of folks, just from a DR perspective, it's an important feature, or compliance. There's just a lot of reasons to have it. So. We have that for MySQL, but not for Postgres today. So yeah, today we do it inside of one region and not across yet. You can copy snapshots across regions. So we have some customers that take snapshots on a regular basis and just keep copying those snapshots across. And the nice thing is that those are differential. So Osgun's waving at me. Hi, well, no, yeah. Yeah, okay. I know. Thank you.